Hello, dear students. This is Dr. Chofi, and we're going to continue with our research on COVID, looking for some possible associations between population density and rate of infection and rate of deceased. Okay, so this is what we need to do to move it forward. I just selected one of the spreadsheets here with the data. As you can see, in the columns, we have the nation, the total number of people in that country, then the area, surface area, then population density, then you just did the number of infected and the number of deceased. So we're going to work with columns E and G now. I'm going to generate a new columns here, I and J, columns I and J. We're going to be the percentage of infected people in that country. Percentage of infected people in that country. In column I, and column J is going to be percentage of the dead people, of the deceased people for each country. All right. So let's first write the titles of those columns so that it's informative and we know what is going on inside the column. So this is percentage of infected. And then the next one is percentage of deceased. All right. Now, let me just review with you how to do a percentage, okay, so that we're turning the absolute numbers into relative numbers. For example, column B is an absolute number. That's the actual number of the population. Column C is the surface area. It's also an absolute number. Then column E and J and G are also absolute numbers. But for example, column D is a relative number, relative in the sense that it's a population density. It's relative to the number of people in the country divided by the area of the country. And that's why the population density will vary from nation to nation. But when we look at these relative numbers, we can compare. And we can say, for example, here Israel has 391 people per kilometer square, whereas Iran has 50 people per kilometer square. So we can say that Israel is more densely populated than Iran, all right, and so forth. So these numbers that are relative numbers, we can compare them to each other and see the relative population density for each nation. Whereas here, this is not informative because in Israel, for example, it's only 8 million people, and in Iran, it's 83 million people. So we would think that Iran is more densely populated, but it's not. It's not more densely populated because it has much more territory, okay? And so when we do relative numbers like a density, for example, then we can compare the numbers one to the other from each nation. That's the same thing that we're going to do here when we turn these absolute numbers of infected and absolute numbers of deceased, of dead people, into percentages. Then we can compare. We can compare number percentage infected to percentage dead, and we can also compare percentage infected from one nation to the other. All right, so these two columns are going to be very informative for us. And here's what we're going to, once we have this figured out, we can do some statistical analysis on this, all right, and see if there's some trends or some, yeah, basically some trends or associations between percentage infected and population density, for example, or percentage dead and population density. All right, so first you label your columns up here, and then you go into the cell, the first cell, which is going to be in this case I2, cell I2, and we're going to do an operation. We're going to do a percentage, right? So equal sign, and then to do a percentage, it's essentially a fraction, right? It's a fraction, it's a division multiplied by 100. to make it a percentage. So you see the symbol already is telling you, the symbol of percentage is already telling you what the operation is. It's a fraction multiplied by 100 to make it percentage, right? Per 100 individuals, etc. So every fraction, every division has a numerator and a denominator, right? So the numerator is above the fraction, the denominator is below the fraction. And so the numerator is going to be always the smaller number. That's why we come up with essentially it's going to be a decimal. Every percentage first starts as a decimal. It's a two-step thing. First, you do the fraction, and you come up with a decimal number. And then that decimal is multiplied by 100, which may or may not turn into a whole number, all right, depending on how small the fraction is. But the numerator, in order for us to get from a fraction to get a decimal, then the numerator has to be the smaller number, and the denominator at the bottom has to be the larger number. Okay, and that's how we get a decimal number, less than 1. Okay, so the smaller number, we're going to do percentage infected, right? So we go to infected. The numerator is going to be the absolute number of infected for that country. There it is, E2, and then times 100. So we put it right up here. The times, the multiplication sign is above is the asterisk, above number 8 on your keyboard, above number 8. So you do shift number 8, and that gives you the asterisk, which for the spreadsheet, for Excel, the asterisk means multiplication, just like the / means division. So now we got cell E2 times, right, times 100 to make it a percentage, and then divided by, which is the / divided by /, and then we pick up the denominator, which is going to be the number of individuals in that country, the population number, not the population density, but the absolute number of people, all right? So this is our operation here, is the number of infected times 100 divided by the total number of individuals in that population. Once you have that operation laid out, all right, or written up, then you hit enter, and that does the calculation for you, all right? So you notice here is 0.347%, all right? This is a decimal, but it's a percentage. It's not 3.4% or 34%. No, is 0.34%. Okay, so it's less than 1%. It's about 1/3 of a percent. 1/3 of a percent. All right, it would be like on $1, it would be 1/3 of a penny. All right, it's less than a penny, so it's less than 1%. And that makes sense because, you know, the population is a relatively large number. If more than 1 or 2 or 3% of the whole population were infected with coronavirus, we would be in big trouble. Essentially, the healthcare system of those countries would be overwhelmed, all right? So typically the numbers are gonna be less than 1%, and it's still very significant as far as human beings are concerned, because that means that, you know, more than a quarter of a million people, human beings, are infected in Iran, even though it has a population of 83 million people. All right, so once you have the first cell done, then you pick up the cross at the bottom of the cell, the lower right corner, just like we did last time, and you click into that cross and you scroll down. And that will repeat the operation all the way down to the last country that you have, right? And then release, and there it populates. Okay, now, a couple of things. Of course, you know that the scrolling down moves the cells down by 1 etc. So that this last cell here, you can click on the last cell and you will see it gives you up here in the f of x, right? F of x, which is equal to y, the y coordination, is equal to E47, all right? So it came all the way down to row number 47. It's still picking up E, which is the number of infected, but it is now on row 47. So it's picking up, for example, B47, which is the total number of that particular country. And the 100 stays by itself because the 100 is put in here in an absolute number, as an absolute number. It's always 100, right? So the 100 is not going to be changing from cell to cell because it's an actual number that we punched in. But the other cells defined by a letter and a number, those scroll down in coordination, if you will, and so that the data is true for each cell, all right? We still need to do a couple of things with this column. Scroll back to the top, if you will, and or you can pick it up from the bottom here also. We need to get rid of too many decimals. These are just way too many decimals. It's not informative way down here. It's not that accurate, okay? The numbers are not that accurate. So we're just going to deal with two decimals or two decimal points, meaning we're going to go down to centesimal. In other words, decimal and centesimal, and we'll stop there. So we're going to average up to 2 decimal places. To do that, and to do it for the whole column, pick up on this one cell, click in to the last cell here, click in and scroll up so that you're highlighting, notice how it's turning gray. You're highlighting all of the cells that we just calculated except for the title. All right, so you bring it down to the first informative cell here, which is I2, right? And now you release and you have all the data set that we just generated, you have it highlighted. And now we're going to average up. We're going to average up to 2 decimal places. So you come up here on the bar, on the ribbon, on the home ribbon, okay? And you look at this button here in numbers, under the numbers tab, you see that it has a little arrow that pushes in to the right, okay? From, you hit on this little button here, and this will reduce the number of decimal places one by one. Even if it scrolls around, don't worry, just keep going and you'll see how it's reducing the number of decimal places and it's adding up, okay? So if it's 0.5 or 0.6 or 0.7 or 0.8 or above, it's going to go to the next number up, right? If it's less than 5, it's going to go to the number below. So keep hitting that little button until you get to 2 decimal places. In other words, decimal and centesimal, and there it is. 0.01, for example, for Mozambique, 0.05 for Morocco, 0.24 for Montserrat, etc. At some point, when it's always a 0, we just don't say the 0, we just start with a decimal point and we say 0.01, 0.05. Also, we don't say 0 many times, we just say O instead of 0. So 0.01, 0.05, 0.24, 0.41, 0.01. Look at this, here's one that has a whole number. That's a 1%. In Mayotte, wherever Mayotte is, that Mayotte has 1% of its population infected according to these numbers. And you see, it makes sense because look, they have a population of about 250,000 people, 272,000, right? They have 250,000 people in the population. And look, about 2,000, close to 3,000 are infected, all right? So 3,000 of 300,000 is 1%. All right, so you can see that it makes sense. It makes sense, the data. All right, so you can scroll up And you can see that it's all two decimal places, right? We still need to do one more thing, which is the 0.00. You look at these, for example, in this case, it's Kiribati, wherever Kiribati is, we actually had no data, right? Remember I asked you to erase the zeros and put no data where you had no data, because 0 is different from no data. In fact, 0 is a number. 0 is a number, and no data is no data, okay? So no data is not 0. Okay, so especially when we talk about number of infected or number of dead. So we need to come back here because the computers are dumb, you know, and they don't know. They cannot interpret that there is no data there. They interpret it as 0. And therefore, we need to erase these 0.00 because he was just doing the operation automatically, okay? And therefore, we need to erase those 0.00 and make sure that they stay blank because there is no data there. So again, now it's different from this one, for example, where you have 0.00, but it's got 20 infected. And what happens is that 20 out of 7 million is less than a decimal point. So that actually brings to mind that we need to select down to millésimos, otherwise we'll miss this data here, okay? Again, let me repeat that. Look at the case of Laos, okay, where we have actually 20 cases of infected. There are actually zero dead, and that's a real number because that's from the WHO source, the World Health Organization, all right, but they do have 20 infected. It's just that 20 out of 7 million population is down to millésimo. It's not at the centesimal. So we lost that number, and that number is informative. So that means that we need to correct this and go down to 3 decimal places to be able to pick up that little piece of data, okay? So let's do that. We have to go back to the bottom. It's in there, don't worry, all the data is in there. So we have to do the same. Again, highlight the whole column except for the title. Go back and this teaches us further how to use Excel in case you didn't know these little tricks. Maybe you all knew it already. Anyway, so you highlight the thing again, the whole column, and you go back, but now you use the other button here. You want to expand the decimal places. So you go to the other button on the left and you hit it once. Okay, and now it's giving you 3 decimal places. You're down to millésimos, right? Decimal, centesimal, millesimal, and let's go back up to Lao and see if now it picked up that data. So let's see, here's Lao. Let's highlight the whole row. No, it's still not picking it up. Wow, okay, so well, that means we need to go back again because 20 cases is gonna be very small. Let's see how many decimal places we need to show to pick up that data. Okay, so let's go back and let's do one more decimal here. Now we're 4 decimal places. Keep it highlighted and just go to Lao. There it is, Lao. Is this okay? Now we picked it up. Here's Lao. Okay, and now it picked it up. It's 0.0003% of the population. 0.0003%. So 3 decimal, centesimal, millesimal, 3 10 millésimals of the population are infected. 3 10 millésimals. That's extremely low. Okay. Now, unless these numbers are underreported, they must have done something right with 7 million people and only 20 infected. We assume for now that the numbers are correct. But this would be also a signal. This would be like a red flag to see how accurate this number of infected is, all right? But so far, just from first sight, this is the least infected country of these 47 countries or 45 countries, whatever they are, all right? So you see how the data is beginning to be very informative. Okay, so we leave it at the 10 millesimal or 4 decimal places. For now, leave it there. You may have to adjust your data more than that, but try to go to 4 decimal places, and we try to keep it standard that way. All right, we still need to clean up. Here is another blank, right? So this is a true 0, 0, 0, and this other one also is a 0, 0, 0, right? So this actually no data. Erase those. Here's another one blank. So we need to erase that data, and I think we have it. You can scroll up, for example, here. Okay, blank, blank. This one, no, this one has infected. So we're looking at infected. All right. Keep going. Okay, here's 2 blank. Okay, good. So it looks like it's done there. Do the same thing for deceased, right? So figure out the disease the same way we did here, but make sure that you're in this cell here and you're picking up now. You're going to pick up for the numerator. Which column are you going to pick up? You're going to pick up column G, right? And the denominator is still going to be B, column B. All right. And don't forget to multiply by 100. So do these calculations, clean up the data, and send it back to me for revision. And then we go from there. All right. Okay. If you have any questions or doubts or comments, please call me or email me, and let's keep it moving. All right. Okay. All the best. Bye-bye.